No one's mentioned IDS yet.
Just take a guess. I mean,
Nope.
Backup fail.
Nope.
IDS.
Huh? Nope. That's a good guess.
Whoever was involved in the compromise told you.
No, but it's a good guess.
all right, one last guess. I think we covered
Anyone?
pretty much everything except this.
Except the one. Hmm?
I had one where the server was more secure than when we secured it.
I wish I could say that was it.
The only one I haven't seen out is someone saw one class.
In a way, that's close. I guess Jay, you can randomly throw the hat out or give it to him. Actually, what we've seen more often than not is an external entity, such as one of the internet watch groups, like SANS or MyNet Watchman or DShield, something like that, or a government entity literally calling you up and saying, "Hey, guess what? Someone broke into your system. You've got a problem." It's actually not the entity itself or anyone belonging to that entity figuring out that there's an incident. It's somebody else coming in and saying, "Hey, you've got a problem. You might want to start looking at it." So for all of you that get those weird phone calls that from this random person, "Hey, you've got a problem," you might want to take them seriously because that's actually it's working. These people are correct.
You want to talk about how the external entities work and what it is that they do?
So in our experience, we've seen a couple different groups. What they're doing is they know about some type of persistent threat that's out there. So in the case I was just talking about, the financial sector, there was one major group of attackers that was going out and breaking into a lot of different institutions. So obviously that gets noticed, right? The government starts to take notice, individual watch groups start to get noticed, and people have their little pet projects to start monitoring them. So what they do is as they monitor them, they start to see different entities that they're compromising. So these groups are then calling up those companies and saying, "Hey, look, you've been compromised, you've got an issue." Most companies will then come back and say, "Who are you? We don't believe you, go away." They'll then call back and say, "Fine, here's some proof that I see that you're compromised." Now the company starts to say, "Oh my God, maybe he's right, they do have a problem." They usually will then contact their local law enforcement and say, "Hey, verify this. Is this the Secret Service really calling me? Is this the FBI calling me? Is this one of the internet watch groups? Are they for real? Are they legit?" Usually that local field office will go ahead, corroborate the information, and then about a week after they're initially notified, the company now realizes that yes, this is a legitimate problem. They need to take action on it right away.
Yeah, it's quite amazing how that works. Your detection capabilities, I mean, you'd assume work, but they don't.
And actually, one more thing. In that case, one of the companies we were at least, the IDS had actually caught the fact that there was a problem, but his company had all alerting turned on by default. They weren't even looking at it. So yes, their IDS had actually caught the fact that there was a problem, but they didn't know because they weren't looking at it. So.
All right, so let me describe the layout of this one company that we're talking about in this instance. Fairly typical. They had different security zones. They had a DMZ that hosted their internet-facing web applications. They had a secure zone that hosted the databases that formed the backend tier for their web-facing applications. They also had a corporate network connected on a different zone. Fairly, as far as the security program went, they had both critical and non-critical applications on their hosted on their web servers. They had a program that consisted of manually performing penetration tests against their critical applications, hardening of their database servers, as well as providing for egress filtering and ingress filtering on the different zones, mostly on the database servers. So given this layout and the security program they had in place, let's talk about what is the methodology that the attackers use to gain access to the environment. So in the next few slides, we're going to be talking about just a few snippets of the methodology that the attackers use and some of their techniques. It's not going to be a comprehensive overview of how it is that they can compromise a network. All right, so this is probably the more generalized version of the methodology. After SQL injection is found, then there could be any number of ways by which SQL injection can be found. We'll talk about it briefly. We'll talk about it briefly later on. But they initially try to exfiltrate data through error messages, and once they have some information on the kinds of data that the database server hosts, they try to gain access to the network through stored procedures. XP command shell is the most often used stored procedures. Stored procedure, if that doesn't work, they use ad hoc queries like open rosette and open data source. And if that fails, they resort to link servers. And so what we'll do is follow the tracks of this one attacker on this environment and see how the group or he gained access to the network. So now briefly, how do you detect SQL injection? There are three generic ways. One is in-band, where you inject your SQL injection tags, and the messages that the server sends back to you indicate that it's not validating your input. So through the error messages or through SQL error messages that are returned back to you. The second way would be out-of-band, where you don't know, because of perhaps a customized error page, that the application is actually vulnerable to SQL injection. What you then do is assume that the fields are vulnerable and inject some tags that allow the remote database server to connect out to a server that you control. And then there's inference-based, where you can perform a timing-based attack, where you have the database or the application wait for a certain period of time before it returns the response. So three generic ways of finding SQL injection. We'll not talk about how to find SQL injection. We'll just assume that they've successfully found a field that's vulnerable to SQL injection, and then talk about how they exfiltrate data and gain access to networks. So what they do is try to gain information about the backend database to see if it contains data that is relevant. Does it contain social security numbers? Does it contain credit card numbers? And the way they do it is mostly through in-band injection, where they input some injection tags and look at the error response. And oftentimes, the error response doesn't provide them the details of the data contained in the database, right? It's just going to say, the application failed to run this query, or whatever. What they have found is a pretty decent way that we found to work all the time to return information from the databases, and they do this by using the cast method. Essentially, what they're doing here is, if you look at the snippet, what they inject into the SQL, into the vulnerable field, is a query that allows them to query the backend database. And what they then do is cast the output of that query to nvarchar and equate that to the number 1. So this information is always going to report an error, because what they're doing is comparing an integer to a data type of nvarchar. So what cast essentially allows you to do is convert data types. You can convert data types from strings to integer, from integer to nvarchar, or whatever. The reason they cast it as nvarchar and equate it to 1 is because they know that it's going to be, there's going to be a problem with this query. And what you'll see is the database responding with an error saying, conversion failed when converting nvarchar value, followed by the response of their SQL query. In this case, it's a database that is contained in their database server. So master is is your main database that's in your database. What they can then do is just go through and actually query all of the information from the database, and it's going to work all the time. You can query tables, you can query fields, you can this is it's a fairly good way of getting information out of the database. So once they've gotten information about the database and they know that it contains information that they'd like to have, information like credit card numbers and social security numbers, what they then do is try to gain access to the actual system. And what we'll see in the next few slides are a few ways they go about